When you send a request to the server, you get a response. That is what we covered in the system design basics till now. But in some cases, we don't want to process the response as soon as you send the request. You can delay the processing for some time. You would still have to send a response, because if there is a request, there must be a response. But it is not necessary to do all the job when the request came. So we will understand this with the help of example. We are talking about asynchronous processing. So generally, what the model is that we have a client, we have a server, and we simply make a call and to the server, and we get the response back. So this is a synchronous API call. So this server does whatever it has to do on the backend, make the database call, store something, whatever it has to do, it does it when this request comes. And there is some API latency, like suppose you send a request at some time, how much time it took to actually give you back the response. So suppose 1 second, 500 millisecond. Major thing for a developer is to reduce this latency as much as possible. But now suppose that all of the things which are being done by the server in the backend, you don't have to do everything. So how will you prevent that? In some cases, it is required that there is no response required just at that time, or maybe you're not requesting anything. It is possible that you sent a request to actually trigger something in the server which you might need in future. So what we mean by that is, for example, let's take an example of Netflix. Suppose you watch 10 different movies. Netflix stores that at what point you stopped a particular movie so that you can resume watching from the point you left. So this data has to be stored somewhere. So even though you're streaming the content through the Netflix CDN, you want to resume from this point itself after some point. So at every time you have to tell Netflix, you have to keep making an API call that I'm at this point, and you need to send these events, even though those events are not important for you. They're like at that point while you're watching the movie, they will be important for you when you actually want to see at what point you left. So how will you design this type of thing? There are different devices. From this you make a call to the API gateway. This is a synchronous call. This API gateway makes a call to the playback API at the back, and finally what it does, it stores this event into the cache and also into the database. And after this storing is done, the response is sent back to these devices. Suppose whatever time it takes. This would have been fine if it is not streaming. What can go wrong in this type of design? So suppose while saving into Cassandra, something failed. There is some delay in saving to Cassandra because some host got overloaded, the writer actually got overloaded. So if this is taking time, that means that the response when you send back to the user, that will also take time. This is what we call back pressure. Now this back pressure would keep on increasing if these types of issues are propagated back to the client. So what Netflix thought, or you would also thought, that viewing history is not important at the time when you are actually streaming. Your streaming experience matters the most. So this task which we are doing, storing into database, storing into the cache, this can be done by the server at some other time also. We don't want it to happen at that particular time. We are not expecting any response that would affect our streaming experience, which is there. So they thought, why not make this call an asynchronous call? So this is one of the example where you can use asynchronous processing, where you don't want the response right away. Or the other reason is that you want to invoke something which is a very long running thing, and the API call would take 5-6 seconds in responding back. So what they do, simply introduce a queue in between. So now what would happen is that you would send a request, the playback API would just put this request into the queue, you would get an acknowledgement back, the event you sent has been in the queue, and the request is successful. So the response actually is this acknowledgement which is being sent when you have put the data into the queue. Well, this definitely will solve the issues, but not at the Netflix level. Netflix operates like millions of users every day. They still have to think of a lot of different other things. So what are those other things? Let's talk about those. The first thing is data loss. So what if one of the clusters get damaged at some point? So all these messages which will be saved in this Kafka cluster, they will be lost forever, and they will not be able to store this history into the request process. So what's the solution for this? Introduce another cluster is one of the users, but you don't want all types of data to go to these clusters. So for example, you will just try to push the critical data to both the clusters. Some data you might be just needing for your own purposes, which user might not even check ever. So you can decide what data to push to each cluster and what to push to both clusters. Now one argument in this that you might be thinking, that what if while publishing the message to Kafka itself, the request fails? You don't get the acknowledgement back. What will we do in this? If the broker from which you're writing the data, that broker expires or there is some issue with that broker, you won't be able to write that request and you won't get the acknowledgement back and your request will fail, and that would also lead to data loss. So how will you handle this? We'll understand about that in some other video. Now the second issue which comes is processing latency and auto scaling. If there are millions of users, they'll keep putting the events one after the another, and the time for the playback API to push this can increase because of the high load. So you have to auto scale this so that the latency of actually sending the acknowledgement itself does not increase somehow. Also there can be issues on the consumer end also, that if the consumers are not scaled to get that much number of messages, they might not be able to process all of them. So you have to auto scale your services so that wherever this kind of condition occurs, whenever there are large number of messages which are being input, now you might be thinking what will be the parameters which you will decide on the basis you want to auto scale. So you must consider something that if this criteria breaches, will scale more. So Netflix used the records per second. So it used the number of records which are coming in per second and used it to scale the number of consumers. Now the next big issue is out of order. So it is possible that in asynchronous processing which you are doing, you want the messages which are coming in order. In Netflix case only, for example, suppose you're watching a movie and you watched it till time t, and then you again started playing it and watched it till t1. Now Netflix should store that you watched the movie till t1 instead of t. To make this happen, these events should be in order. They cannot break the order. So to make this happen, you have to adopt different types of techniques. What Netflix did is they give a timestamp in each of the event which they are sending from the client. Another thing which you can do is use a counter which keeps on increasing for each of the event which is sent. This is kind of keeping a distributed counter, which are not mostly preferred, and timestamp is kind of a better approach, and that's what they went with also. Now another thing is the processing failure. So for example, you took the messages in this Kafka queue, you said that it will be processed and do whatever job it was doing before, like post it to the database or the cache. But now suppose that the request fails. Now if the request fails afterwards, what do you do with this message? Do you discard this message? No, you cannot discard this message. To prevent this from happening, we have a queue called delay queue, and now these messages can then again be pushed back into the Kafka and processed later. So this is quite a common way to actually do asynchronous processing, that you have one main queue which is getting all the messages. If some processing fails, the messages are pushed into the delay queue, and then from the delay queue these messages are pushed back to the main queue. Now when will these be pushed back? There can be different strategies, that you send the message as soon as it comes to your delay queue or wait for some time. So there can be different strategies which you adopt. Now this was all the producer part, that your queue is generating, the client is generating events, the queue is consuming, which is kind of the producer. There must be some consumer platform also, like which will be doing these processing, consuming the events which are coming through Kafka. So for this you can use microservices, you can use some consumer platforms which are available. There are a lot of open source consumer platforms also which will be able to process these events which are coming from Kafka or any type of queue which you take. So this was all about asynchronous processing. Main thing to think about in asynchronous processing, you're not sending the response as soon as you send the request. You're doing some processing in the back, and you have to keep in mind these things, that these requests can fail also. It is possible that even writing to the queue fails. All of these things you have to think about. You have to make a choice, that will you go with asynchronous processing or synchronous processing.